All right, so this is an introduction to 3D art pipelines. My name is Michael Fletcher, and this is basically, from my experience, things I've learned after doing it one time. I've only done it once, so after doing it once, there's things that I wouldn't want to do anymore, things that I wish I would have done, definitely would have done, definitely will do if I do it again, and just a lot of things that I wish I had known, like before I even started at all. It's a whole bunch of information. It's like scatterbrained. It's a whole bunch of topics I'm going to be covering. So let's go ahead and move on. Basically, the art pipeline, it starts from the modeling software. This can be Blender, this can be Maya, this can be 3ds Max. You start from there, you export your file format to file formats such as, you export your art, either your model with your 3D animations, to file formats such as FBX, Wavefront or OBJ, Kaleido, etc. And then you get into your game engine. Now, a better art pipeline would be the same thing, except you take that exported file format and convert it into your own custom file format before going into your game engine. It's a really simple concept because say you support one of these file format types. You make a converter to convert it to your file format, and the import into your engine, you write that one time. It loads into your engine one time, you know it works, it's tested, everything like that. If someone wants to add support for a new file format, you simply convert it to yours, and then nothing else changes in the engine. You can do an offline converter that, there's no dependencies involved with that. It's a really simple concept. It allows for, it saves time. All right, working with artists. You should know the lingo of your artists. Sometimes you guys can be talking about the same thing and have like different names for it, and you won't even know that you're talking about something. So like you may be having a conversation, and something they're saying is just going over your head, and you're like, well, I don't know what they're talking about. I don't know. I'm just gonna keep on doing whatever it was I was doing, or something like that. Or you may be talking to them saying things, and it's just going over there, and like, I have no idea what he's talking about. I hope this is what he wanted. And then you get something, maybe a week later, 2 weeks later, something down the line, where, just communication, stuff like that. Simply make sure you understand. If you don't know something, learn it. Ask for help. Especially knowing the tools that they're using before you even start. Like, what experience do they have? Do they have experience with Maya? Do they have experience with Max? Anything like that, ZBrush. What are they going to be using? Photoshop. All these tools. What are they going to be using to create your art? That way you know the capability of those tools. You already know what to expect. You can also find out what it is that they like and dislike about those tools, because there may be certain things about those tools that slow them down, and you could simply write a little program really fast that will save them iteration time. It could be a simple feature that they don't have, one simple feature, really simple, that they don't have in one of those programs that you could provide them with, or one feature that they really, really, really hate that slows them down that you could help speed that process up. And then there's also critical must-knows, things you must know about those programs that will just crush production flow. Not knowing that this one export setting is necessary for this to work for this program, but not the same in this program. You may think that it works all one way. And then simply, once again, what formats does it support? Oh yeah, we need FBX, but this program doesn't even export in FBX. Or we need a Kaleido format or Open Kaleido format, and this software doesn't even export in Kaleido. Things like that. It could be textures. So this is like 2D. Your engine may not support 64-bit depth textures. And they use Photoshop, and they're using 64-bit depth because they want those nice range of colors. And then whenever you load it into your engine, it just shows up black. When you get a black texture, if you're a graphics programmer, there's a list of reasons why that texture can be rendered black. There's a list of reasons. And how would you, is the first thing you're going to do is think that, oh, maybe it was the actual texture file before it even got into your engine? You're going to be going through debugging your code, stepping line by line, trying to figure out what's wrong, like why is this black, looking at render states and stuff like that. Something you did may be something you did wrong. when actually it's just simple. Maybe if you're using OpenGL and the specific texture converter or importer you're using doesn't support 64-bit depth. So maybe, you know, DirectX may support it, and then this specific library that you're using doesn't support it. And it was a simple thing such as, I mean, a simple solution to simply go back in Photoshop, exports 32-bit depth, done. That saves you hours of debugging, all these different things like that. That's wasted time. So just know the tools, try to know as much. And this has nothing to do with programming. Just knowing this will save you a lot of time whenever you actually do start coding. All right, so basically the modeling and animation software, there's 3 key things that I feel like some of the major things. Units, materials, that's like an added feature. It's not really necessary, but it can save time if you do have that functionality. And exporters and plugins. They're starting with units. Almost every program handles these differently. So this comes like linear units, angular units, and time. So linear, that's like meters, millimeters, inches, feet, yards, stuff like that. What units does this program work in? Angular units, is it radians or degrees for their rotations? Do they use quaternions or Euler angles? Things like that for whenever you're interpreting this data. Time, what's the frame rate for the animations? Is it 24 frames per second? Is it 60? Most time animations won't just be 60 frames per second, but you know, whatever the frame rate is, it could be 30, 24 frames per second. There's settings like that, and you, whenever you're doing your importing or getting the data, that's important for how you set up your keyframes and your interpolation as well. Now, display units and working units. You may have taken care of this, and you guys sat down with the art team and the dev team and the designers and everything like that, and you came with a up with a consistent, I guess, a consistent process where you guys decided upon, okay, everything's going to be in meters, right? Direct3D and OpenGL, they default in meters, so just model everything in meters, animate everything in meters, do everything in meters, right? So you may have agreed upon that. And the artist is like, all right, meters, got it. And then they go and they set the display units to meters, and they think they did a good job. They're like, okay, we communicated well. There's going to be no problems. Everything works. And you just go. They're gone. They may have spent like, you know, some weeks on this animated model. They rigged it. So first they modeled it. They unwrapped the UVs for it. They modeled it, rigged it, unwrapped the UVs, animated it, all this stuff like that, right? Long process. And then they go to export it. And turns out working units was still in centimeters. Your display units was in meters. And that's what it looked like on screen. They create a cube. They say your character is 5 meters tall. They create 5 cubes. Let's put it next to the model. It's about 5 meters. Okay, good. That's what it looks like from the display. And now you export, and in your engine, it ends up being, well, you probably don't even see it. Either you don't even see it, or it's really, really, really small, stuff like that. That's just something to keep in mind. Scaling issues, that's one of them. But there's also this other situation that I ran into personally. I know in Maya and Max, the export settings, there's this thing called a scale factor. I believe one of them there'll be like 0.001 or 0.01, and I'm thinking, okay, so they multiply by that, but actually they were dividing by it. So they were scaling, they were actually, you know, making it bigger. And then the other program does the opposite. It actually does multiply by it, so it's like saying, you know, 1/10 or 1/100th of whatever the actual units are. So, you know, the whole centimeter to meter, meter to centimeter conversion, stuff like that. So there's a way to test this. I mean, to avoid that, you can simply start with text files, ASCII, export your FBX file or whatever as ASCII, and just open it up and look at it. And you start off with a cube. You create a cube. That's, you know, 1 unit. You look at the vertices. Is it -0.5 to 0.5? Whenever you export it, is it still that? Or did it jump up to 50, -50 to 50? That happened to me. Default units, I think I just said that default units for Directory and OpenGL are meters. Materials, this is like when they're inside of Max and Maya, you can apply materials, textures, different shaders and stuff like that. And the artist can do that while they're modeling. They can see what it's going to look like right there in Maya and Max. They don't have to leave and test and you know, fiddle with your text files or your shaders or ask you to see what it looks like or you know, export and then load it into some separate program. They can do it right there. So, you know, it'd be nice if the artist could the exact same way it looks in Max and Maya as the exact same way it looks in your engine. Of course, you don't have Max and Maya as renderers, so it's never going to be exactly the same, you know, depending on implementation, but you could get pretty close. The whole key is, if I create a material and I apply this texture for this diffuse texture on it, and that's it. Just something simple as that. You got a material, you got a texture, maybe a modulation color or something like that I applied to it. And whenever I export my model, it'd be nice to have that material, all that data in that one file as well. So FBX does support that. It's all in the FBX file when you export. In order to get that in there, you have to choose the embed media export option. That will save all of that information in there. I recommend starting off with like the standard material types in 3ds Max and surface material types in Maya. These are the standard. I've never done this, but I know UDK does it, and this is how far they've gotten so far. I played around with it. I've seen, you know, that's another thing you can do. You can, before you even start working on your art pipeline, open up UDK, something like that. Artists love it. I know my artists love it. Artists in the school, you know, they love UDK, right? It's beautiful. You can mess up the lighting, and the lighting still looks good. Things like that. So, but my point is that if you actually go through the pipeline, be like, I'm going to just do this thing right here. I'm going to go to the process of exporting from Max or Maya and then importing into UDK. Let me see what is the process like for this engine. And then you see what features were necessary, what features you don't really need, how they handle certain things, certain settings and stuff like that. And you can get an idea of what you want for your iteration, for your workflow, for your pipeline. And the next thing is communicate what you do and don't support with artists. If you're working on a material system, if you're working on getting the material data information directly from the FBX file, don't just be like, oh yeah, you can just export the materials. You know, tell them exactly. If you only support Lambert and Phong, let them know that so they don't waste time. But if they are making a Lambert and Phong, they can go ahead and just export it with it. You know, it saves you guys time. You know, this applies to everything else in your pipeline. Communicating with your artists, letting them know what you support and what you don't support. It'll help your relationship all together and workflow, because they're not wasting time doing something and then not getting any results. You guys aren't expecting things and then not getting any results. All right, exporters and plugins. You can write your own custom plugins for Max and Maya to where you can actually avoid some of those you can actually avoid some of those intermediate file types. So you write a plugin, or you can still export in one of those types and maybe make some adjustments. Maybe you don't like the way the data's laid out. Maybe you may want to do some computations right there in Max. So say maybe tangents, and by tangents, maybe you want to calculate those yourself for some reason, right? Maybe you want to flip them for a specific, because of your engine or for some reason. You could do that after the fact, or you could do it right there in Maya or Max before you even export in the FBX file. So the FBX file already has it set up for your engine, and you just use it as usual, and no one even knows. Pretty much it. Unit conversions, stuff like that. The whole scaling issue. Instead of having to scale it whenever you import it into your engine, or scale it, you know, maybe before you do that, maybe in a cooker or something like that, you could scale it before you even export it right there in Maya in the script. It's just another way of another convenience, another option, another place to actually do the exact same thing. All right, file formats. Binary is fast. text or ASCII files. It's readable and easy to debug, like I explained earlier. Some file formats I've had experience with: FBX, Collida, OBJ. Collida is open source. There's a lot more tools out there available for Collida. FBX, you know, it's powerful, it's popular. Artists are probably the artists here are probably going to want to give you an FBX file. OBJ, this one doesn't support animation data. So, but if you don't have any animations in your game, you only have static meshes, this is one of the most simplest file formats out of all of these. So if you're not going to do animations, and you know you're not, go for the OBJ. And remember the whole convert to your own file format thing. Maybe later on you may want to support animations. You still may want to convert the OBJ file to your own file format. Because say later on you do start adding other file formats, or maybe your own custom file format that's not listed here, or someone else's custom file format that they have for some reason, you can still convert their file format to your custom file format for your engine and then just import it. So the FBX SDK. This is one way of extracting the information from the FBX file. There's the FBX API. You extract the data you care about. So you can avoid even getting data you don't care about in the file, like cameras, if you don't care about stuff like that, cameras, lights, things like that. But essentially, the FBX, they provide an API, like node graphs, stuff like that, for actually going through, connecting the dots. The information is there. It's not the best documentation. From my experience, it does get better with each year. Simply looking at the 2010 version and looking at the 2013 version. If you just look at the chum file that just comes out, 2013, I was like, oh look, they have classes that actually have names, like a mesh class. You know, not these acronyms and pointers and nodes. Like it was like a whole lot more C-based and tree node-based setup with the 2010 SDK, and then the later one, it's like classes, members, methods, and stuff like that. You just call. It's really nice. Well, better, a lot better. But still, FBX is still a very complicated file format, and it's very time-consuming. It's not that hard to do. It's not the most complicated programming. It's just very, very time-consuming. And being a DigiPen student, we don't have a lot of time. Another option, Open Asset Import Library, also known as ASIMP. This supports multiple file formats. Unfortunately, last time I checked, it still doesn't support FBX. They claim to be working on it though. They do support Collida, Blender, 3ds, OBJ, .x, a lot more file formats. It's free. You can use it for free under the GNU license, I believe. Really nice API interface. It's like you load the file, you get a scene pointer, and you access scene. Does it has meshes with a method that returns a Boolean? Has meshes. Check if has meshes. You go to the mesh member. There's an array of meshes right there in the scene class. So you just check that. There's another member for how many meshes. So you set your for loop up, loop to less than the number of meshes that are in it. You've already checked if there are meshes. You also could have checked if there was 0. You know, that's another way of checking, whichever way you prefer. And then you go through the meshes. You see, does it have vertices? How many vertices? Exact same process. Does it have indices? How many indices? Exact same process. Tangents, bitangents, were there normals included? So, like, if has normals, use those normals. Or you can calculate your own normals if they don't. If it has tangents, use those tangents. Or you can calculate your own tangents if it doesn't. So you can just have these cases like that. It's really, really simple. Also, another way of quickly setting up error testing, like if you definitely do need that information exported and you forgot to click one of those export options, you can quick error message. If has this, else, so error message, there are no blah, blah, blah in the file. Communicate that to the devs, to the artists immediately, maybe in a model view or something like that, and they can go right back, export it again, something like that. It's a lot less complicated than the FBX API. I liked it a lot better. Now, the next one is the one that I never got around to doing, but looking back at it, from never doing it, if I had never done it before, this would be the first one I would try. So I came across this in one of the Frank Luna books. I think it was the Directory, the 11 book. He said something in there that really reached out to me. It was like, if you don't have a whole lot of time to write your own converter, DigiPen student, don't have a lot of time. I was like, that's me. So he's like, if you don't have a lot of time, you can use Open Asset Import Library. That was how I heard about that too. I heard about that from that book, and I started looking it up. I seen it, I learned about it, and said, or you can use XNA. Of course, XNA isn't supported now, but the version that did exist loaded FBX just fine into its own mesh class. You simply load FBX in XNA, it uses C# in the mesh class. It's right there. You have the vertices, all the information is right there in XNA's mesh class, and then you just use C# to write it out to your own file format. Done. You didn't have to go through some API. You didn't have to go through some if this, if that, if this, if all of this, build this tree, get these bone names, all this stuff like that, build this hierarchy yourself, all this stuff. You just load it in XNA, get the data, spit it out to your own file format, load it into your engine. This is definitely what I would do first. It seems like the most quickest way, especially whenever you're just trying to get something up and running. All right, tools for artists. Probably heard this before, but you know, it's important. And I know whenever I was doing mine, I remember I was like, oh yeah, I'm gonna do all that stuff. And then, you know, I was just, whenever I did have something up and running, I think I remember I was like, oh yeah, drag and drop. Yeah, that's like so easy. And go do that in like 2 hours or less, something like that. So drag and drop, really, really fast, immediate results. You wanna make this interchangeable, make it where you can hot swap. Meaning, so changing a texture, just drag a texture on there to see that this texture, or I wonder what this texture looks like on the model, just drag it on there. I wonder what this normal map looks like on there, drag it on there while it's running. You don't have to close the program, do this from file. Also, this leads into like a model viewer. That'd be nice. Artists don't want to go through all your loading screens and your loading assets and all this stuff for your actual game engine to go to some hacked level you made just for them to look at stuff in your actual game. Now, of course, you still want to use like the actual rendering engine, your graphics engine. Definitely that's ideal because the model viewer will look exactly the way it does look in your game. Automation, that's really nice too because you can automatically detect if a file is changed. It automatically shows those changes. You can do that with inter-process communication with Maya or Max. You can, when they export, go ahead and put it in the exact file directories of your game engine, exactly where it's supposed to go. Textures go into the textures, models go into the models folder, missive maps, normal maps, all this stuff like that. Detect real-time visualization of changes. So that was it. I think that was it for that slide. Model viewer, I just talked about that. Artists should communicate their wants and needs. I know I worked with my artists, and it was like, I wonder if they were too nice. But I was like, come on, what is it you don't like about this? Come on, what will make your life easier? I'm just like asking them, come on, tell me. And eventually I get something. I was like, all right, I'm going to do that. All right, I'm going to do that. And it was, you know, I get it to them, and they'd be happy, and, you know, I'm happy. And I'm like, all right, what's next? What do you don't like? What do you don't like? And, you know, just simply doing that, asking them what they want. I didn't have to sit up here and be like, oh, yeah, this feature, or what else, and, you know, spending all this time. I can spend my time exactly on what they wanted right then and there, what they wanted in order of what they wanted. And in the end, I look at the product, and every feature in there was a feature that they told me that they wanted. And it, you know, it shows, you know, that artists are happy using it. It builds a relationship with the artist. You can communicate with them. They understand like how long it took you to implement those specific features just for some tool. Hotkeys, UI, stuff like that, things that they may want. They may want buttons. You may have a weird artist that wants to type. I know usually artists, they don't want to touch the keyboard. They just want to point and click. Let's see. 3D animations. So 3D animations, you can have them, they can be either, so you could have 3D animation where you just have it could be per vertex. You just have a mesh, one frame, a mesh that looks like this, and maybe another mesh that looks like that, another mesh that looks like that, and you just switch between the meshes, kind of like textures. Of course, that's a lot of memory. But then there's also the joint or bone hierarchy method, where you do interpolation using keyframes, where you just say, this is one keyframe, this is one keyframe, and then time 0, I'm right here. At 1 second, I'm right here. So, and that's all you give or you have, right? So it saves memory. And then you simply interpolate over time from that position to that position, that rotation to the next rotation. So you linear interpolate on position and scale, and then for your rotations, you're going to do a spherical linear interpolation. And you use quaternions. These are convenient for 3D rotations, and also the gimbal lock problem is solved. So if you're not familiar with gimbal lock is basically whenever you have, your Y, your yaw, pitch, and roll, in whatever order that is, and always the one in the middle. As soon as you rotate that by 90 degrees, you lose. If you're not using quaternions, you will. If you're using Euler angles, you simply lose an axis of rotation. Now, so if you did do yaw, pitch, and then roll in that order, you now, if you change your pitch or your X rotation by 90 degrees, and then try and change your Z has now just become your Y. Your Z and your Y is the exact same axis. You just lost your Z axis. So this also is a problem if you're doing animations, because you're interpolating these rotations. So you may think that gimbal lock is only related to cameras and stuff like that, but in animations, if you're using Euler angles and you're interpolating these rotations, getting from one position to the other, eventually you're going to hit one of those angles and bam. And that's whenever your mesh goes crazy and your animation goes crazy simply because of that. Or your mesh just doesn't show. So that's why we use quaternions. Data-driven. Having a single data file containing all animations, this is one method. You use a method such as cut sheets. This is simply having all the animations on one timeline. I did it like this. This was nice. It worked. You just say that one animation is from this time to this time, and if from that time to the next time you have another animation, and if from that time to the next time you have another animation. So basically you just say the keyframes. You say from frame 1 to frame 5 is this, from frame 6 to frame 9 is that, and then depending on the frames per second, this is where the whole time thing with the units comes into play. The actual time, if it's 24 frames per second, will differ from if you were at 30 frames per second. So you're saying start at 0.6 seconds. This is where this animation starts, right? If you're running at a different frames per second, that time is completely different. I did it like this. It was easy to specify. I just had, I'll show you later. I simply specified the start frame and the end frame, and then the animation speed. It was a float value. Skinning. Skinning is when you take the vertices and the joints. So you build this skeleton, and you had this mesh. And skinning is whenever the bones move, the vertices move the way they should in relation to the actual joints. It's kind of like my hand right now. I have all this skin. That's skinning. I didn't know what skinning was whenever I first started. I was like, I heard the terms, stuff like that, talking to artists, don't know the lingo. I'm like, okay, this is what I need to go look up. What's skinning? I don't know what that is. hardware scanning. So it's basically, you want to do all this stuff in software first, in C++ if you're doing C++, so that you can debug it really easy. Using Visual Studio is really nice. You can step through the debugger. You can check to see your bone weights. You can check to see your in transforms, your matrices, your bone matrices, and whenever you actually apply them to the vertices, as if you were. So basically, software skinning is when you take exactly what you would be doing, like if you look up any like implementation, if you've done any research on doing hardware skinning for the performance. You just look at the exact same thing you're doing in your Vertex shader. You're just going to do that per vertex on the CPU. It's slow, of course it's slow, but as soon as you get it working, then you go to the GPU and you take advantage of the speed and the hardware. Passing data, debugging shaders. This is a place that I ran into. I spent some time because it's simple. Me thinking GLSL, HLSL, they have these things, these data types called int, in some of the later shader models and OpenGL profiles. They have ints and int4s, vec4s, float4s, stuff like that, right? It's an int4. If I have these 4 bone indices for my bone weights, or for my vertices, right? I'm like, well, I'll just pass it as an int4. That makes sense. There's this function for me to pass it as an int4. Still don't know why, but I would get invalid data unless I passed it as a float. I had to pass it as a float, otherwise I would get invalid data. I spent a lot of time trying to debug this, and it was simply that, just changing it to floats. Because I'm using the newer APIs, I'm doing a new way, but all the old examples, the old documentation, you'd see floats everywhere. I guess that still holds. But debugging shaders, simple things like that, just a big assumption that, okay, this makes sense. Why wouldn't this make any sense? Why wouldn't this work? Costs a lot of time. That's why software skinning, if I know it's working in software, then I know that there's something going on here. It's not the code. It's not rewrite the code from scratch because I probably made a mistake and I just can't see it. If it's working up there, it's probably most likely. And this is always working with shaders. It's a lot of times just passing the data to the shader. Next thing is column major versus row major matrices, just something to look out for. Mismatch vertex declarations. This is another thing I ran into. I think it was when I set up my vertex declaration, you can set up whether you're passing a float 3 or a float 4 floats or 3 floats. I think I still had, I was saying I was passing 3 floats, because I was passing 3 floats, and then in the shader, 3 floats for my position, I think. It was one of those. In the shader, I would be having a float 4 for the homogeneous point. And then DirectX simply wanted to be nice and set that 4th slot to, actually it was for my weights. You wanted to set that 4th slot to 1 for me. And weights are supposed to total to 1. And since I accidentally messed up my declaration and I put 3 floats there when it should have been 4, it set the 4th one to 1 regardless of what I was sending it. I always set the 4th one to 1 because it's expecting me to send points in, and it's going to set the W to 1 for me, being nice. So instead of totaling 1, it was 1 plus whatever my weights actually were. That screwed up my mesh at one point. That's the next key, the normalized weights. Picks for Windows, this is another help for debugging that. This is actually how I found out I had help debugging it. And we looked at the actual data I was passing for that actual set when I set the vertex stream. And I looked in there and I'm like, I don't set a 1 anywhere in my code. I just knew that I didn't. I don't set a 1 for the 4th component anywhere. I didn't set that. I'm like, how is this 1 here? And then it clicked in my head, and I was just going checking that pipeline, and I found out that I had 3 floats there instead of 4, just a typo. Game engine integration. So I'm going to go over the model and mesh class, the animation system, and then the animation system architecture. So the mesh class, it's simply the geometry. You want to separate this from your model class. And because a mesh class is more like a resource. You treat your mesh just like a texture, just like a name or a string. And that's exactly how I had my setup. It's really easy to set my mesh. That way, I could actually drag and drop my meshes in my model viewer and just, oh yeah, just set the texture. It's not gonna break. Just set it. It's just like setting a string to whatever I just pass into a function. So literally just the geometry, nothing else. Animation data, simply, I thought I had something there. I thought I had a code sample right there. I didn't update the slide. But simply the data for calculating the final matrix transformations to apply to the mesh just before you render it. So this includes simply your final bone matrices for your hierarchy. So the way keyframes work is you have a keyframe. A keyframe is your position, rotation, and scale for every frame of animation. So if I was like this, it would be the position, rotation, and scale of every single joint in the hierarchy. And then as soon as I go to some other frame of the animation, or keyframe, is the position, rotation, and scale of all of those. And then the interpolation is interpolating from there each and every keyframe. So that's what the whole after you apply that interpolation, right? You get the actual time t, and you interpolate it. You get that final value. Then you build your actual matrix using the scale, rotation, and translation, and then for each and every joint or bone. So however many bones you have, that's how many matrices you're going to have. That's your final transforms. And then those final transforms are what you're going to use to do your skinning. So this is what I talked about earlier, non-skeletal versus the per vertex. Per vertex is the one where you don't have skinning. You have a whole bunch of meshes, and you just interpolate. You literally interpolate each vertex itself. Instead of interpolating the joints, you interpolate vertex to vertex for each mesh. So assuming that the mesh has the same number of vertices, and you're simply just changing poses for every single mesh, you're just interpolating every single vertex. This can be expensive, but a lot of games, to my understanding, I did some research, a lot of games in the past, you'd be surprised, simply just did per vertex animations. It works. Skeletal hierarchical animation, data-driven, per instance data versus shared data, animation wrapping modes, and usability. This is what I'm going to talk about now as far as the animation system goes. I just kind of put like highlights of what I'm about to talk about next. So the non-skeletal per vertex, change from mesh to mesh, I kind of just jumped into it and talked about it. So I said it's similar to sprite sheets, and it's basically what it is. You have this thing, you move it a little bit, you have the next frame, you move it a little bit, you have the next frame, you move it a little bit, you got the next frame. That's literally how per vertex or non-skeletal animations works. So a lot of vertex data, I said that. Sometimes this is mixed with skin animations. Yes, so I did some research on this. I've never done this, but I did some research on it, and I saw where this is definitely important and kind of cool. It was kind of cool whenever I seen it. So imagine you have skin animation, you're doing these interpolations, right? Especially whenever it comes to the rotations, and you have this hierarchy for as far as the models, the animator just animating like a robot doing some kind of flips and flying around, and then he's hanging from a pole. So basically this relates to your root bone. So say your root bone is right here, right? In the pelvis, like, that's the common place to have a root bone. And then if I'm hanging from the ceiling, I'm swinging like a monkey, then it'd be kind of nice if my root bone was up here now. So you would switch your mesh in the middle of the animation. So while flying up there to the ceiling, my root bone may still be in my pelvis, but then I grab the ceiling and you immediately switch the mesh or the hierarchy to where the root bone is up there now, and that was basically a non-skeletal switch or animation, if you will, and then the interpolation is applied differently because the weights as well are different for that mesh. So skeletal hierarchy animation. This is what I did. I know a lot more about this than the non-skeletal. So keyframes, interpolation, and the animation data is separate from the hierarchy. So this is what I was talking about when I explained keyframes. This is the actual time in the animation for where that orientation, scale, and rotation should be. And then you have the local position, local rotation, local scale. That's local for that actual specific joint. Now, of course, you have to take the parents into account. You have to do this yourself. You have to take your parents' transform into account so that the hierarchy and everything is within the bone space or the mesh space, the skeletal space, before applying it to the model space and then world space. And then you have tracks. This thing called tracks, when you think of animation track, is just a list of keyframes. So the number of tracks I have should be about the number of bones I have. So the number of joints I have. So if I have one keyframe for every single joint, my tracks is the list of all joints, or keyframes for every single joint. And then you have an animation, and that's the full duration, the full time or length of the animation. So say my animation is a 5-second animation. So over the course of 5 seconds, you have all of these tracks that are going to take place. All these tracks, animations, keyframes that are going to take place during that duration. And then you're going to interpolate over that, which contains all the keyframes, which contains the time and position, rotation, and scale for every single joint. So your animation system can also be data-driven. You can have multiple files containing different animations. I didn't go this route. Several people do. It works just fine. I did the single data file containing all animations and animation segments or cut sheets. So basically, if you look over here, this is an example of the text file. I don't know if you can read that, but I think I show it later and it's bigger. I simply have for in-game logic. So this is, we're getting closer to game logic. This is all animations from frame 0 to 150, and the animation speed is 1, so the time scale. And then I have the win animation. It's like a wave animation for like on the pedestal for whenever you win. It's from frame 102 to 150. Jump animation, knockback, run, and idle animation, and then the speeds. Basically, it's strings. I just use strings. They worked. So I have the name of the animation. So in code, the designer or whoever's writing the game logic is simply going to write set animation segment and type in that, whatever that string is. And all that other stuff is taken care of from the data file. And whenever I want to add more animations or say we updated the data files, I don't have to recompile any code. We just swap out the animation file. It has more keyframes in it. Cool. Maybe we added some more frames after 150 and we have more animations now. I just add to that text file, and now in code, the designer just calls this new text file. Types in the string for this new animation that just got added. Maybe a fly animation, so just now we're flying. Simple. Per instance versus shared data. So this is so that you don't have every model using a specific animation at the exact same frame of animation. So of course, one thing you want is those final bones, that final transformation, the final transformation for every joint that you're going to send to the GPU. That should definitely be per instance. So that's whenever you're setting up your architecture for your animation system, you want to identify these dependencies, separate them for whenever you're setting up your classes. I just add a pointer to a single mesh. Like I said before, my meshes are treated just like textures. So this is how you want to do it. A texture should definitely be shared data, because the texture doesn't change unless you're rendering to it or updating it dynamically. But generally, if you got a texture, you got a normal map. Your normal map's usually not going to change. Your specular map's usually not going to change at runtime. So why do you need a different copy for every single model. You don't, right? Same thing goes for animation data, specific animation data, materials, things like that, meshes, your hierarchy, your joints, if you have those separate as well. Another part, animation rapid modes. This is kind of just getting fancy now. Basically, it's what do you do whenever you reach your last frame of animation? Do you loop to the beginning? Do you clamp there? Do you start playing in reverse, going back to the first and then start going back again? Do you play one time and just stop? Clamping is a pretty cool thing because it's like you just clamp on the last frame, and say some of your game logic would be to start adding frames of animation to the end of it. So if you clamp to the end and you just added 30 more frames of animation, all right, we're animating again, and then you clamp there. You could also remove some frames of animation and you go back. So this is basically, it was a really simple way of really simple way of making that data driven. Just had a wrap mode, and I just used some functors for each different wrap mode that I supported. So like looping and clamping, and just had a different update method that actually handled that, what happens whenever you get to the last keyframe. So usability, the C++ interface, changing animations to C++. This is what I was talking about whenever I was saying just simply set animation segment run, set animation segment jump, set animation segment fly. This is basically the end using result of your animation system. This is what your the developers and designers are actually going to be using. So you want to make this really nice. You don't want to hard code it. You want to expose only what's needed, and then other features that you may want. So strings are easy and flexible. I did that. I was like, it's not my bottleneck, just do that. Could have did some enumeration and done some stuff with ints, but at the end of the day, it wouldn't have done anything. It wouldn't have done a whole lot more than we already had. That was a note to myself, code samples go here. I think that slide is out of order because I did update that slide. Yeah, I think this slide is out of order. Sorry about that. So animation controller, this is the high-level interface that the person doing game logic is going to interact with. All this other stuff is going on behind the scenes, all the stuff we've been talking about so far. No one cares about that. These are the people using your interface now. They're simply just call this animation, set animation speed, set animation, stuff like that. Pause animation, play animation, these type of functions. This is what goes here. So whenever you're setting up your animation system, you want to think about that. Keep that in mind, always in the back of your head. Even before you start on the actual, I just need to get something working and looping forever. I don't care. I just need to get something playing. Keep in mind, eventually you're going to want to play this animation, pause this animation, change this animation, set the animation speed. You're going to want to do things like that. This is where you have this concept of the animation controller that comes in. And it manages the state of which animation should I be playing right now. So you could have some kind of AI involved or some state machine that will determine what animation should be playing, what type of animation blending should be taking place, depending on those type of animations that should be playing as well. I hard-coded it. It turned out something like this. I didn't have an animation controller class. It was just part of my model class. But I ended up with something pretty decent. It's like if player's not jumping and if the player is running, we simply call this one function, set animation segment, pass in the string run. Now we're playing the run animation. If we're stunned, because game logic says we're stunned, this is basically like the whole state machine concept. We have a knockback animation for I just got knocked back, I'm stunned. If I'm idle, just set it to idle. If I'm jumping, then set the jump animation. And this is basically the information in the animation segment. I just had the name of it, really easy for the string lookup. The start time of animation, the end time, that's in the time segment in the cut sheet. So if all the animations are on one timeline, that's basically start and end frame of the animation for that specific animation. So say my run animation is here, and then my knockback animation is here, and my idle animation is right there. That's basically what that is, the start time and the end time. And time scales, how fast do I want to move? Do I want to play this animation in slow motion? Am I stunned? Am I moving really, really fast? Stuff like that. This is just some code to show you simply how I set the animation segment. Literally just using a string. I used a hash map. I didn't care what order it was in. Little optimization for if I'm setting the animation to something that already exists. I just return, don't do anything because it'll mess up my animation time. Stuff like that. And then some error messages for if I'm trying to switch to an animation that doesn't exist. So that's always nice. Animation state machine is the next part of it. If you actually do this, what you just saw was my animation state machine. This is basically how far we got. It worked just fine for us. Use this for my project Aztec. That was our state machine. Are we jumping? Are we running? Are we stunned? Are we idle? That was pretty much it. But of course, you may have a game that's a lot more complicated. You may have blending and all this stuff involved with your animations, and a state machine would come in handy. State machines also handle things like attachments. So if you wanted to get a bone, if you wanted to attach something to a bone, like a sword, you would have to get the name of that joint. The state machine can handle that. That could be a layer. That could be a layer that's, that you set up the interface for doing things like that, for attaching objects like that. You set it up to be able to get the actual name of the specific bone or the joint that you're looking for that part of the object, referencing that. You can also attach extra joints to your hierarchy. Maybe you at runtime you're attaching joints to this hierarchy that already exists. Of course, it doesn't mess up the animation. It's just a joint that's that's become a child to something that's already there. So if I added a joint that's a child of my hand, that way it doesn't have anything to do with the animation data. It's always just wherever this hand is going, it's going to go. Because I just added this joint right here. It's going to go there. You just made your own joint. If you set up your architecture like that, you don't have to have the artist go in and add a joint to the model for you just because you did something in game logic that you may be scratching later anyway. And if you set it up like this, you can add the joint there. And then you have that bone. You just added that joint, right? You can give a name to it yourself. You can name it yourself. You can reference it wherever it is you're referencing it in game logic. And simply place your sword right there, wherever this is. And that'll come in handy right there. Here's a bigger picture of what I was talking about with the whole data-driven aspect of the animation cut sheets. It's the exact same picture. I just had the name, start frame, end frame, and then the animation speed or the time scale. And then there's your animation pipeline. This is the low level. I went backwards. This is the lowest level. Your inputs is your mesh, your keyframe, your cut sheets is what I talked about earlier. Current start end frames. You want that on a cut sheet, which gets converted to the start and the end times later on. So that's what I was talking about, where the frames per second gets converted into the actual time on the actual animation timeline. And then the current time is what you use to actually do the interpolation. All of this, whenever you're calling set animation, play this animation, no one cares about that. Your designers don't care about any of this. They just want to play animation and everything works. So whenever you're doing it, keep those 3 layers in mind. It also includes any blending information. Also, they don't want to have to handle that. They wanted that to just happen. They want it to be nice and magic. I thought I'd put that on another slide. So basically, this is basically how your final Bernoulli matrices look. You have a matrix. You have a vector of matrices. That's your final matrices that you're going to send to your GPU. So our pipeline issues to look out for. You have pivot points. It's a really simple concept. Whenever you're modeling in Max or Maya, think about the origin of the model. You want to create your meshes at the origin, because whenever you load them in your game engine, it's like it's at 0, 0, 0, but the body's right here. That's what pivot points. That's where pivot points come in. So remember that. Remind your artist. Your artist may not notice. They might just be modeling, and they put the mesh up here, and the skeleton over here. You know, just organize it nicely, stuff like that. But you know, right before you export, just either move the pivot point to where it is, or just move everything back to the origin if the pivot point's already set up. Also, if you have a skeletal mesh, this kind of changes, because now your pivot point is your root bone. So the pivot points don't even matter anymore. It's wherever your root bone is. So if that's a pelvis bone or wherever it is, that's when you say 0, 0, 0 or 1, 1, 1 is the position where you're putting this into your game engine. Wherever the root bone is, that's where 0, 0, if you say 0, 0, 0, the root bone is going to go to 0, 0, 0. So pivot points, keep that in mind. Non-skeletal animations, detecting this. So this is another issue. So if you do have non-skeletal animation support and skeletal animation support, you have it's a simple thing, detecting and separating this in your architecture. So detecting, do you have a skeletal animation? Do you have bones? Do you not have bones? Handling that. It wasn't really one of the big things, but you know, it was a bug I did run into. It was like, oh yeah, just check if it has bones. All right, done. How many bones does it have? 0. All right, cool. Bind poses. I really don't understand the whole point of this. The whole point of, because I thought I understood it, and then I was just, I guess, turned into a liar, because apparently the Autodesk Autodesk SDK completely ignores the bind pose. I found this out a while ago, that I was trying to figure out why the model was spaghettified in my after I converted it in my engine, and then in Autodesk thing it worked just fine in the Autodesk viewer. So you know, Autodesk, they give you the SDK, and they give you their actual the source code for their viewers and stuff. So I actually went in there to sound like, what are they doing that I'm not doing? And turns out when they take the bind pose, they delete it, they remove it. Like, so whatever your bind pose was, they just took it out, and they use this thing called a transform link matrix, and they create a new one and throw it in there. So if you do have a spaghettified or distorted looking model, keep in mind not having a bind pose or having a bad bind pose is could be one of the causes of that. Another issue is triangulation. So you can have manual triangulation, automatic triangulation. Manual or automatic, it's pretty much the options you have. Either the artist can model the mesh with triangles from scratch throughout the whole way through. Just model the whole thing with triangles. This is the best because they have the best control over it. Or you can do automatic triangulation, which you may end up having triangles in wrong places you didn't want. So if you had a cube, you may, or it may have, it's kind of hard to just describe. It's easier for me to just show a picture or show it to you. See if I can pull this up. I thought I had this. Here's Maya. So this is a cube right here. You notice right here, these are just quads. These are four-sided. These are four-sided polygons. There's no triangles in here. So doing triangulation, they could do all kinds of weird things. They could have it go like this, or it could go like that. Which way is it going to happen? I don't know. It could be front-facing or back-facing, things like that. The normals and everything like that can get flipped. Well, not flipped, but the faces could be rearranged during triangulation. So if you triangulate, now, okay, we have triangles now. This is basically what we mean by triangulation, because you're going to need triangulation for whenever you send your data to the GPU, unless you support quads, which I guess is nice, but typically you're probably going to want triangles. So the thing is, you can triangulate in your cooker before you import into your engine, or you could triangulate after you import into your engine. But going down the line, it just gets worse and worse because you have less control and cleanup that with each step down the line. So, of course, modeling with triangles is the best, but the second best is simply triangulate before you export. It's also an export option. Another problem you could run into is axis conversion. Is Y up, is Z up? That's a really simple thing. But yeah, things like that are things to look out for. Another thing is animation controllers and modeling software. Does your pipeline support this? So I know Maya, they have like some scripts and stuff telling it what to do along the line whenever it's animating. Well, there's a baking option that helps with this because if you don't support that, they just bake it and spreads it out into just keyframes, which is generally what you want. Scaling issues with 3ds Max and Maya, I went over that a little bit, but there's some more points I want to touch here. So first thing you want to do is you want to start off with meshes that don't have joints or bones or anything in it. Just start off with a cube, export that cube, get that to work. When you're testing scaling, for scaling issues, like the example I gave with the whole -0.5 to 0.5 and then -50 to 50, if you can get it to be 1 meter in Maya and then 1 meter in your game, all right, good. Now add a joint to it, add a bone. You'll be surprised. All I did was add a bone to my cube, export it, and now it's scaled up by 100. Why? Because things like scale compensation, joints taking parents into account, and simply the FBX exporter in general just does stuff. It makes these assumptions. And then non-uniform scaling issues as well. These are things to look out for. And then the next thing I can say is just find a solution that works for your engine, because there's a lot of documentation. And if you notice, like, I'm not just telling you a specific way about going about implementing things, because things are going to be different between your art pipeline and my art pipeline. Your artist, the tools they use, the way they go about creating their geometry, all these things are different. So when you go online searching for a problem or reading documentation, sometimes these are for general situations and not specifically your, and sometimes answers are for their specific situation. And a lot of those, I just found a lot of documentation just be wrong for my situation. So the way I found my solution was I went through this process. The exact same process I just told you about, the cubes with joints, without joints, and then Max and Maya, all these steps, because Max defaults to inches, Maya defaults to centimeters, Maya defaults to centimeters, and then, you know, the whole working units thing, and Maya supports scale compensation, Max doesn't support scale compensation, all these things like that. So if you have data coming from Max and then you bring it into Maya for the animation, and then you export from there, along the way data got changed, things like that. So there's all these different variables, so many different variables, and then whatever it is you do in your cooker before you get into your engine, all these different variables going on, to where the best, like my best advice is just you do your own testing, you come up with a process that works, you be like, okay, this is well and tested, this is how our pipeline works. This is the steps that we remember this. Make presets. I don't remember if I talked about presets yet. So presets are another big thing for all these export options. You definitely want to use presets, because whether or not to triangulate, whether or not to export tangents or bitangents, whether or not to smooth geometry, all these stuff like that, whether or not Y is up, whether or not you triangulate, all these things, you can just make a preset and be like, all right, just select this preset. You can give it to your whole team. This is a preset we use for this type of geometry. This is for this type of model. Here's a preset we use if it's animated. Here's a preset we use if it's static geometry. And then they just one click for this, one click for that, one click for that. And you don't have to remember all the export settings. You set it once. Sighting on units, I talked about that. Also another thing, maybe there's units that's just easier for people to work in. So if you guys decide on a specific unit that's easier to work in, depending on the tool you're using, that could also change whether or not you want to model in meters or model in centimeters, things like that. So you want to come up with this, like before you even start, communicate with your artists. Be like what are you guys more comfortable working in, and or how can you guys be the fastest with generating content, and then you just make a simple scale, and done. Everybody's happy. The per mesh scale factor. This is what I ended up having to do for my testing because of that. The whole, if there's a bone in there, then it scales it up by 100. And if there's no bone, I still don't understand it. I was just like, I don't have a lot of time for this. Screw it. I'll just do my own per mesh scale factor. I realized it just hit me in the head. I was like, oh, this is why Unity does that. This is why they have the import little scale factor thing in there. Okay, that's why that's there, the little 0.01. When you import it and everything gets scaled by 0.01. Because they know FBX. They know it. It's the exact same thing. So I thought it was me. I thought it was just me or something I was doing this whole time. But if you're importing on Unity and the default scale factor is 0.01, it's because they know that FBX got scaled up by 100 for some reason. So things like that, and just testing. Also, it's like, okay, so I know when my artists, they give me this thing from Max for some reason, they're modeling in inches. I can just be like, all right, for this specific archetype or this specific prefab, set the scale factor to this because I know that this came from Maya. Or this came from Max and it was in inches or something like that. So I need to scale, I need to convert this back to our units. So you want to test, find out what's most convenient for your artist and your editor, your tools and stuff like that. Find the easiest thing for everybody. And my debugging tips is testing your full art pipeline from start to end. Start with cubes, export options, presets. I knew I had this slide in there. I changed the order at the last minute. Things got messed up. And this right here is the number one. Well, not number one. Everything is the number one thing I can recommend. All this stuff. It's just a whole bunch of information that I wish I had whenever I started. Just something to look at to and refer to. Just if I had this right now before I started, and every time I had a problem, just went through my notes, these notes right here, I'd probably find, oh yeah, I didn't do that. Oh yeah, that right there. Oh, that exists? Dang. Stuff like that. That's pretty much it. Are there any questions? All right, thank you for your time. This is Introduction to Art Pipelines by me, Michael Fletcher. And yeah.